So for this chapter, we're moving into material that hopefully should be among the most familiar you get in this class. At the very least, everyone who took a high school geometry class should have seen most everything that we're going to get here, with maybe some additions and some adjustments along the way. But as I said, it should all, at the very least, feel like stuff that you've seen before, at the very least remind you of things you've seen before, unlike a lot of what we got from chapters 2 and 3, which I imagine were mostly fairly new. Here we're talking about some very, I wouldn't necessarily say basic things, but, well, approachable standard things that you might get from math, where we're looking at geometry. And in particular, we're going to start with the most simple constructions that we have for geometry, which are points, lines, and planes, where a point is just a single location in space represented by a dot. Technically speaking, when you're drawing a point, it should be zero-dimensional because it only represents that single location and nothing else, but obviously by virtue of drawing it, you're giving it some amount of dimension that, well, if you zoom in enough, it'll look more impressive. But the point is that it's just the location. All it tells you is a place in space and really nothing else. So if we want to take something like that and introduce the, let's say, complexity of another location or any other string of locations, then we get into what are called lines, where a line is what represents the shortest path between 2 points. It's just a connection between them, along with any other collection of points that get touched along the way, where technically speaking a line is meant to go on forever and ever. That's what those arrows mean. So we can get some other constructions in here with what we're looking at as well, where we can have what are called half lines, which we generate by taking one of the points we're looking at and removing it with that open circle and then letting the other side go on. Then we get array if we fill in that place, if we fill in that open location, and then we get a line segment if we cut off the other end, and we just have the almost little barbell shape there between the 2 points. And the nice thing about this section is that even though there are a lot of notational details to chase around, a lot of types of things to have to think about, usually it's pretty straightforward to understand what we're looking at just in terms of the pictures that are formed by these constructs. And then from there, if we want to take our ideas, our discussion here of points and planes, and add more information, more directions, more dimensionality, we can take the whole thing and just flatten it out, spread it all around, and get what is called a plane, where a plane is, in some sense, the shape in space formed by 2 intersecting lines. That's probably what you're used to thinking of it in terms of the rectangular plane of algebra. But really, a plane is just a flat surface. It's just a 2-dimensional shape in space formed by, well, 2 axes. But again, that's a little bit more algebraic than maybe we really need here. So if you want a very, very brief example to see how this actually works, you could think of a plane as being something like, well, a map. Not a spherical coordinate map that tries to emulate the roundness of the Earth, but let's say you have a flat map and you want to represent a single location on that flat map. So you want to talk about FGCU, you would put a point on the map at FGCU. And then if you want to take it further and talk about going from FGCU to somewhere else, you could draw a as the crow flies line from FGCU to Miami, or really anywhere else you want to. But just to get an example, you can think of it in that way with a construct like so, where again, the purpose, don't want to say point again, is to just get some basic visualization of what sort of pieces we're going to be playing with in terms of 0, 1, and 2 dimensions, where the next thing we can look at is what happens when 2 lines run into each other in terms of the rotation between them. We're going to be looking at our angles next.